Okay. Here's a review of simple interest. I'm sure you've seen simple interest before. Simple interest occurs when the interest is earned only on the principal, the initial investment or the initial loan, okay? So interest is only calculated on the initial amount you've either invested or you've borrowed. So interest equals principal times the annual rate of interest times time. So A is the accumulated amount, which is principal plus interest. So A is the accumulated amount, any amount you invested with the interest. R is the annual interest rate. P is the principal or amount invested or amount borrowed. I is the total interest earned or paid. Let's do an example. Anna deposits 600, so there's three formulas, right? This one and this one is basically the same thing, just a different format. So Anna deposits 600 into a simple interest account. As soon as you see the word simple, you know interest is earned on principal only, or the amount you invest. Anna deposits 600 into a simple interest account at 4% per annum. Annum is the Latin word for year, for 3 years. What is her balance at the end of the year? So we want to know how much she'll have in total at the end of the year. Should we use this formula, or that formula? Which one makes most sense? We want the total amount she has at the end of the year, so we don't. The third one. Let's try the third one. A equals P, 1 plus RT. So the principal she invests is 600. 1 plus annual rate of interest is 0.048. And it's for 3 years. So this is interest rate per year, so the time has to be in years. And that's 600 times 1.144, and that is equal to 686.40. At the end of 3 years, Anna will have 686.40. Yes. Well, we could have used the second formula, but do you agree that the second formula, here's the second formula, okay? A equals P plus I, and well, to find I, we need this formula, right? And that's the same as the second formula. So you might as well use that formula. Right? A equals P plus I. Interest is PRT. Right? Interest is PRT. Factor out the P. That's your second formula. Can I explain anything else? John invests $100 into a simple interest account. In 90 days, I guess that should be for 90 days. For 90 days. And his accumulated amount is 108.75. What was the interest rate? Well, let's see. What was the interest rate? What do you recommend I use now? Huh? The first one? Okay, we could use the first one, but we're needing. Why don't we use the second one, because we need an extra calculation. So A equals P plus I. So the accumulated amount is 108.75, and that equals 100 plus I. So our interest is equal to $8.75. So we just had to calculate out of the 108.75, what was the interest portion, right? I equals PRT. Now we can start calculate the interest rate. 8.75 equals 100 times R times T. So 90 days, we need to convert this to years, so I'm going to divide by 365. 8.75 equals 900 over 365R. So R equals 8.75 times 365 over 90. And that is approximately 0.35486. So that's the interest rate was about the interest rate was about 35%. Oh, I wish they paid that now, boy. But then we'd have horrendous inflation. Yes. Oh, Michael? That's okay. Isaac, you had a question? Oh, okay. First, we need to know how much of that was interest. And then, so interest equals PRT, and we solve for time in years. T is time in years. We should add that up here. T equals time in years. Compound interest. This is compound interest occurs when you earn interest on the principal and the accumulated interest. Okay? So just to give you a simple illustration, let's say the compounding period is 1 year. And we'll say the interest rate is 5% and the principal equals 100. So after 1 year, you would make PRT, right? After 1 year, your amount would be yeah. Oh, 90 days. Oh, it should be 9,000. So we have to divide by 9,000. Senior moment. You're absolutely right. I'm going to calculate just to make sure it's 8.75 times 365 divided by 9, 1, 2, 3. Yeah. Thank you for correcting that. Okay, so now when our interest is compounded, in this case it's being compounded once a year, we have A equals P times 1 plus RT. So that will equal 100 times 1 plus 0.05 times 1. And we get $105. But now it's being compounded. So at the end of year 2, we're going to earn interest on the $105, not just the $100. So A equals 105 times 1 plus 0.05 times 1. and we will have 110.25, right? So notice how interest is being paid on the principal as well as accumulated interest. Yes. No, because we already did that amount for 1 year, and now we're doing this amount for 1 year. Right? But with the formula, we can plug in, we won't have to do that with the formula. So this, we don't have to do all these steps because of this formula. This formula will calculate it for us. So that's the formula you have to remember for your June 8th test. Remember, this is on your June 8th test. Your test has been moved from June the 7th to June the 8th. That's for your June 8th test, okay? So let's do a few examples of compounding and then present value, and then we'll call it a day. Mary invests $4,000 at 4.5% per annum compounded monthly for 8 years. Determine the value at the end of 8 years. Okay, so A equals P times 1 plus R over N to the YN. So this is compounded monthly. As soon as you see the word compounded, you're using this formula. So the amount she invested is 4,000. 1 plus the annual interest rate is 0.045. And N is the number of compounding periods per year. N is number of compounding periods per year. Okay, so if it's compounded monthly, how many compounding periods do we have per year? 12. And its number of years is 8, and there is 12 compounding periods per year. So try this on your calculator. Make sure you're comfortable with it. $4,000 times open bracket 1 plus 0.045 divided by 12 close bracket to the exponent open bracket 8 times 12 close bracket, and I get 5729.46. Mary will have $5729.46 in 8 years. Can I explain anything? Are we good? Jack hopes to buy a new car in 4 years worth $30,000. So in 4 years, see, this is a future amount, right? This is some future amount. So in 4 years, this 30,000 is A equals 30,000. In 4 years, he needs 30,000 to buy a new car. How much should he invest now? So the principal is what we're looking for. How much should he invest today so he has 30,000 in 4 years? Now they tell us R is equal to 0.089. and it's compounded quarterly. So what is, if it's compounded quarterly, how many compounding periods do we have a year? So now we're ready to calculate it. A equals P times 1 plus R over N YN. So he needs $30,000 at the end of 4 years. How much should he invest today? 1 plus 0.089 over 4. And it's 4 years and 4 compounding periods a year. So P equals 1 plus 0.089 over 4 to the 16. Oh, I'm sleeping. Hold it a sec. P equals 30,000 divided by that, right? P equals 30,000 divided by 1 plus 0.089 over 4 to the 16. And that is equal to, well, let's do it. 30,000 divided by open bracket 1 plus 0.089 divided by 4 close bracket to the exponent 16. And I get 21096.35. He should invest 2109.36 now. This principal is another word for present. It also means present value. In this case, we're looking at, we'll talk about that later. In this case, we're looking at the present value of that 30,000 today, given these investment conditions. How much should he invest today to have 30,000 in the future? Now we're getting a little harder. What interest rate would allow an initial investment to triple over 35,000 years, over 25 years if the interest rate was compounded daily? Oh, wow. So we want our initial investment to triple. So A is equal to 3P, right? It's tripling. Y is equal to 25. And it's compounded daily. So how many compounding periods per year? 365. Don't worry about the leap year. Everybody worries about the leap year. Let's put in everything we know. A is 3P. We don't know R, but there's 365 compounding periods per year. 25 years times 365. Divide both sides by P. So 3 equals P times 1 plus R over 365. 20. Oh, it shouldn't be. I don't know. Actually, later I'll ask somebody if they have a Tylenol or something, because I have a headache. 25 times 365 is equal to, well, it can't equal that. 25 times 365 is equal to 9125. Does anybody know how we can proceed from here to solve for R? Expand that, 9,125. Maybe we could use binomial theorem, yeah? How would you get rid of that exponent? So you took the calculator and you what? So is that a special button or did you go 1 over? Is this what you did, 1 over? Oh, you have a... Oh, you're lucky. Then maybe you can show... Oh, awesome. So 1 plus r over 365. I'd like to know your button. I'd be interested in that. R over 365. Subtract 1 from both sides. So r is equal to 0.0439. So the annual interest rate is about Can you hear me with the fan? Really? Can I explain anything better? We still have to do present value? Yeah, we have no choice. And then next week we'll be in good shape for annuities. Yay! Yes. This one? Well, a power to a power, when you multiply, do you agree that equals 1? Okay. And 3 to that exponent, so I go like this. I go 3 to the exponent, open bracket, 1 divided by 9125, close bracket, is that. I don't know if you can see it with the glare. Because we want to get rid of that exponent so we can solve for this. So we take it to this power because this times this equals 1. Yeah, we've seen that before. Just to say as a simple example. Yeah, let's say you have r equals 3 to the, no, this won't work. 1 plus r to the 3 equals 25. How can we, this is my example, okay? How can we solve for r? Well, I need to, in order to isolate r, I have to get rid of that exponent, right? So I can take this to the 1/3 and take this guy to the 1/3. So a power to a power, you get 3 times 1 over 3 is 1. So 25 to the exponent, open bracket, 1 divided by 3, close bracket, is 2.924 approximately. R is approximately 1.924. Just so you can see another example. Present value. Well, this formula comes from this formula. So if you have A equals P times 1 plus R over N to the Yn, then P is equal to A over 1 plus R over N to the Yn. And what they call this is present value. Or in other words, how much do you invest today to end up with that amount? What do you need today to end up with a future amount. That's what present value is. And the symbolism is basically the same. It's basically what we did here, right? P equals, we solved for P, but they call this present value or PV because it's a present value. It's today's value, not a future value. Okay, Courtney would like to have 1.5 million for her retirement in 13 years. How much should she invest now at 4.75% per annum compounded quarterly? Okay, so what does that 1.5 million represent? A. A equals 1,500, 1, 2, 3. 13 years, so Y equals 13. How much should she invest now? R is our annual interest rate. It's compounded quarterly, so N is equal to 4. 4 compounding periods per year. So, PV equals A over 1 plus R over N to the YN. A is equal to 1.5 million all over 1 plus R is 0.0475 divided by 4 to the 13 times 4. So we can plug that all in. 1, 5, 1, 2, 1, 2, 3 divided by open bracket 1 plus 0.0475 divided by 4, close bracket, to the exponent open bracket 13 times 4, close bracket, and I get 811, comma 884.45. She should, I'll be right with you, she should invest 811,884.45 today to have 1.5 million in 13 years. Yeah? Yep. Basically, yeah. It's exactly the same thing. It's just given a new symbol. Instead of P, we call it PV. I know. Lots of examples. Are we good? Just 2 more examples and I'll collect more study sheets. You'll have till the end of the period. Yeah, when you hand in the study notes. You hope to have 12 grand for your first year of university expenses in 1.5 years. Ooh. You will invest in a financial program where money is compounded monthly at this much per annum. How much money must you invest now? How much interest will be gained over the 1.5 years? All right, so here we go. How much must you invest now? So that's your formula. So the amount you need is $12,000. The interest rate is 0.0525 per annum. Compounded monthly. And the number of years is 1.5 times 12. So let's do it. 12 grand divided by open bracket 1 plus 0.0525 divided by 12, close bracket, to the exponent open bracket 1.5 times 12 close bracket. I get 11,093.16. You should invest 11093.16 now. Now the question also asks, how much interest will be gained? Well, the interest is the difference between 12,000 and the 1193. So interest equals A minus PV equals 12,000 minus 11,093.13 equals 906.84. Therefore, interest earned is $906.84. Can I explain anything better? Yes.
So when you calculate for the answers, we need to put the approximately sign
Um,
on the
yeah, you could. But it's a money situation, so it's a good idea. I don't think I'd take off. Since it's a dollar situation, I wouldn't worry about it too much. Because you have to round to 2 decimal places to have cents, right? So this is a repeat. It's redundant. Do you want me to do it, or do you want to do it? Why don't you give it a try? Make sure you can handle the formula, and I'll end the tape right there. But just do this one to make sure you know you feel comfortable with it.